Okay, 7.4 Rational Exponents. So this lesson is going to take us into rewriting radicals into their rational expression form and then simplifying them in their rational expression form, okay? And so I'm hoping as we get going through the lesson, you're going to start thinking a lot about some connections between this and some math that you may have seen in the past. The first thing, let's talk about how you rewrite it in radical form. So I'm just going to write these in radical form, and then we're going to see if we can make the connection. So the square root of 25 is written as 25 to the 1/2, okay? The third root of 27 is written as 27 to the 1/3, and the fourth root of 16 is written as 16 to the 1/4. Okay, so here's what I want you to understand. We'll call it x to the AB. Okay, this B is the index of your radican. Okay, and this A, the numerator, is the power of the radican. So because 25 in the first example is raised to the first power, the numerator is a 1, and since it's a square root, the denominator is a 2. Okay? Same thing with this. The 27 is raised to the first power right now, so it's a 1/3, and 16 is raised to the first power, so it's a 1/4. But if I decided to change those, like for example, maybe I want to do the fourth root of x to the 3rd. Okay? Then I would have to think to myself, if I'm going to rewrite it, I would have x, the denominator comes from the index, so that's going to be a 4, and it's raised to the 3rd power, so that's going to be a 3. Okay? So the index goes on the bottom, the power goes on the top. All right? So what does that help us for? Well, it helps us, oh, and I'm sorry, I missed this line. I just said that to you right here. The exponent comes from the, well, we won't rewrite it. It's the same thing right there. Power of the radican and the index. I'm not going to make you rewrite it. I forgot that I had added that line in there. So what I want to do before we finish these is I want you to go to the next page, and I want us to think about the properties, okay? So I want us to go look at the properties, and then we're going to come back and simplify some of these, okay? So let's scroll to the next page. And look at the chart with the properties. This is the part that I was hoping would make you think of something else. Okay, such as Algebra 1. This looks very much like what you learned in Algebra 1. So I just want to review this with you first. We have a to the m times a to the n equals a to the m plus n. Okay, so to prove that, let's use this example. A squared times a squared equals, this is so hard in these teeny tiny boxes. Let me try this again. Let's say, so these are the same bases, but they have different exponents. So let's do this. A squared times a to the 3rd. So according to this rule, I'm supposed to add the exponents and get a to the 5th. Okay, so let's actually see if that works. So if I broke down a squared, that's the same thing as a times a. And now I'm multiplying that times a to the 3rd, which is a times a times a. And do I in fact get a to the 5th? Yes, I do. So it is totally fine that when we are multiplying the same bases together and the exponents are different, we just add the exponents, okay? So example, with the actual rational exponents we just looked at on the first page. If I have 8 to the 1/3 and I'm multiplying that by 8 to the 2/3, the bases are both 8s, just like these were both a's. So the bases are the same. I'm going to add the exponents. So that means I'm going to do 8 to the 1/3 plus 2/3. So that is 8 to the 3/3. And 3 divided by 3 is 1. So 8 to the first power, or 8, is my answer. Okay? So we're going to be applying this add the exponents rule. Bases are the same. Add exponents. Okay? Let's look at the second box. Now I have a power being raised to a power. So power raised to a power. The rule says multiply exponents. Okay? So let's see if that actually works. So a squared raised to the third power. I'm going to break it down. According to the rule, I'm going to multiply these out, and I should get a to the sixth. Okay? So let me see if this works. A squared is the same thing as a times a. And I need to do that 3 times because I'm raising it to the third power. So I need to do a times a times a times a times a times a. So I did a squared, okay, 3 times. A squared 3 times. I really hate how those look like L's, but it's really hard to write small in these spaces. So a squared, and a squared. I did it 3 times, and then I broke all those a squareds down. And if you count them, 1, 2, 3, 4, 5, 6. So it does equal a to the sixth. So that does actually work. What does that look like with exponents or rational exponents? Maybe I have 5 to the 1/2 being raised to the fourth. So that means that I have to do 5 to the 1/2 times 4, which is like 4 over 1. So of course when you're multiplying fractions, you multiply across the top and you multiply across the bottom and you simplify. So 5 to the 4 over 2, 4 divided by 2 is 2. So 5 squared is 25. So that's how you would apply it to those rational exponents. Looking at the third one, this is merely a distributive property. That's what I want you to think about. Distribute. Okay? Distribute to the exponents. Everything's about the exponents here. Okay? It's not about distributing to the whole numbers or anything else. Everything here is about exponents. So if, for example, I had a squared b to the third, and I was squaring that, then I am essentially going to be distributing. And when we distribute, we multiply. So that's going to become a to the 2 times 2, or 4, and b to the 3 times 2, or 6. Okay, a to the fourth, b to the sixth. You're going to distribute to the exponents. So again, what does that look like with other numbers? So maybe I have 4 to the 1/2 times 5 to the 1/3, and I'm raising those to the, let's say, 5th power. So I'm going to multiply. So I'm going to do 4 to the, I have to do 5 times 1/2, so I'm just going to call that 5 over 2, and I'll simplify it later, and then 5 times 1/3, so times 5 to the 5/3. So you're distributing that 5, multiply, multiply. Okay? This one I always like to tell my students the stupid story. The stupid stories always are handy because they help you to remember things that you would otherwise maybe not understand or forget. So a to the negative m, I always say that m is unhappy if it's negative. The exponent's unhappy if it's negative. The reason it's unhappy is it's on the wrong side of the fraction bar. A to the m really wants to be in the denominator, the a to the m does, and it's crying. It's squirting out tears. That's what that negative symbol is. And so we're going to make it happy by moving it to the side of the fraction bar it wants to be on. So if it's not currently written in a fraction, you will assume it's in the numerator, just like whole numbers are whole numbers. But when you go to write them as a fraction, you put them over 1. So we're going to do the same thing. When you see a to the negative m, it's not written as a fraction right now, so you can do this. You can consider it a whole number, which means it's in the numerator and it does not want to be there. It wants to be in the denominator. And then once you move it to the denominator, it's happy, so you get rid of the negative symbol. Okay? So we've moved the a to the m to the denominator and we've made it happy. Okay? So that might look like 9 to the negative 1/2. And that means 9 to the 1/2 really wants to be in the denominator. Okay? So we put 9 to the 1/2 in the denominator, and notice we got rid of the negative symbol in front of it. Now, when I say things are on the wrong side of the fraction bar when they're negative, that is strictly for exponents only. Everything we've talked about so far in this chart has been about exponents. Okay, these are things we're doing to the exponents, not to the whole numbers. So if you saw negative 2, a to the negative m, this is the only thing that wants to go in the denominator. That negative 2 is totally fine. This only applies to exponents. Okay? That's really important. So only for exponents. Okay. And then this chart, or the next one, is division. So we are subtracting the exponents. So when you divide, you subtract the exponents. Again, so if I did a to the third divided by a squared, according to the rule I should subtract and get a to the first, or just a. So if I actually, do that out, a to the third is a times a times a, and a squared is a times a. Those would cancel, and those would cancel, and I'd be left with just an a. So that works. Okay? And then the last one, you're distributing that m to the exponents just the same way you distributed up here, except that it's in fractional form. So when you distribute, in this case, you are distributing your m to the a to the first power and to the b to the first power. Okay? So if it said a to the third over a to the fourth, and you were squaring it, you would do 2 times 3 and get a to the sixth, and you would do 2 times 4 and get a to the 8th. Okay? So distribute to the exponents. All right? So let's practice doing this. Let's go back to page 1. Now we'll practice doing all the samples. Okay? So back to page 1. And let's look at these examples right here. Okay. So here's how we handle these exponents. We want to use those exponent rules as much as possible because they tend to make things really easy. So we're going to factor down this 125. Okay, we're going to make this 5 times 25 and 5 times 5. So this is really 5 to the third. So now I'm going to change the 125 to 5 to the third. And remember that that 125, or that 5 to the third, is being raised to the 1/3. And so the rule tells me when a power is being raised to a power, we multiply exponents. So I have 3 times 1/3, and that's going to end up being 1. So now I have 5 to the first, which is 5. Okay? Second example, I have 5 to the 1/2 times 5 to the 1/2. So the bases are the same, which means I can add the exponents. So 5 to the 1/2 plus 1/2. Okay? 1/2 plus 1/2 is 1. So I get 5 to the first, or 5. So we're able to simplify these pretty simply. Okay? Let's do this. Let's break it down. So I have 10 to the 1/3 times 100 to the 1/3. So I can't add the exponents here until I can get the bases to be the same. So is there something that I can change both of them into so they're the same? Or is there something I can change one or the other into so they're the same? So I'm looking at the first one, it's a base of 10. And I'm thinking to myself that 100 is the same thing as 10 squared. So if I changed it to 10 squared, then my bases would both be 10s. And that's sort of the idea. We want the bases to be the same. So I'm going to say 10 to the 1/3 times, and I'm going to change 100 into 10 times 10, okay, or 10 squared. So over here I have 10 squared raised to the 1/3, okay? So I have to do some simplifying. I have to multiply exponents, so 2 times 1/3, multiply across the top and across the bottom, gives me 2/3. So I have 10 to the 1/3 times 10 to the 2/3, okay? And the rule says when the bases are the same, we can add the exponents. Okay, so now I have 10 to the 1/3 plus 2/3, or 10 to the 3/3. 3 divided 3 is 1, so 10 to the first, which is 10. Okay. It would be great if you could pause the video at this point and give 4, 5, and 6 a try using 1, 2, and 3 as your examples. And then when you're finished with them, go ahead and press play and see how they're being done. All right, let's break down the 16 to 4 times 4. So I'm just going to leave it like that. I'm not going to continue. Or you can. It doesn't matter. 2 times 2, 2 times 2. So actually, I'll change it to 2 to the 4th that is being raised to the 1/4. And then again, multiply exponents. 4 times 1/4 is 1. So I have 2 to the 1, or just 2. Number 5, 2 to the 1/2 times 2 to the 1/2. The bases are the same, so I can add the exponents. 1/2 plus 1/2 is 2 to the 1, which is 2. In the third example, I need to make the bases be the same so I can add them together. So I'm going to break down my 8 into 2 times 4 and 2 times 2. So I'm going to change it to 2 to the 1/2. That's too big, sorry. Change it to 2 to the 1/2 times 2 to the 3rd that's being raised to the 1/2. Multiply your exponents. 2 to the 1/2 times, so I have 3 over 1 times 1 over 2. Multiply across the top, you get 3. Multiply across the bottom, you get 2. So 2 to the 3 over 2. Rule says I can add the exponents. So 3 over 2 plus 1 over 2 gives me 4 over 2. So 2 to the 4 over 2. 4 divided by 2 is 2, and 2 squared is 4. So there's your answer. Okay? Just to reiterate a little bit, let's take a moment and rewrite these examples at the bottom of the page. Let's see if we can figure this out. So the bottom is the index, and the top is the power under the radical. So this is going to be an index of 5, and that x is being raised to the 3rd. Okay? Let's think about what that negative exponent means. Okay, let's change the decimal into a fraction. We always want to try to use fractions as our exponents if we can. That's really, really important. So 2.5 is the same thing as 2.5, and we need to change that to its mixed number, or to its improper fraction. 2 times 2 is 4, plus 1 is 5. So I get negative 5 over 2. So y to the negative 5 over 2. Now I know what my index is. It's 2. And I know what my power is. It's 5. But I know that that radical is not happy and it wants to be in the denominator. So the first thing I'm going to do is say 1 over y to the 5 over 2. And then I'm going to change this to its radical form. Okay? Because it's happy. And I'm going to say 1 to the square root of y to the 5th. And I'm going to just have you leave it like that. I know we're not supposed to have radicals in the denominator. I just want to know that you know how to rewrite it. I'm not asking you to rationalize it at this point. You should, if you're working a problem, you should never leave the radical in the denominator. This is just a matter of knowing how to rewrite it. And then now I want you to take the radical and turn it into a rational expression. So this is a root of 2. So that's the denominator, and the numerator is the power. So a to the 3 over 2. Okay, so there are your questions. So it would be great if you took some time to work through 1 through 6 underneath your properties chart on the second page. Take some time to work through 1 through 6, and then check with me when you're finished.